Good morning, everyone, and thank you for joining us to discuss the flexible capacity requirements for 2022 through 2024. My name is Isabella Nicosia, representing ISO Stakeholder Affairs, and I'll be facilitating the web conference today. I'm also joined on the line by our three presenters, Clyde Lutan, Principal Renewable Energy Integration, Hong Zhao, Market Development Analyst Lead, and Jessica Tahiri, our Energy Meteorologist. And then I'm also joined on the line by Amber Motley, our Senior Manager of Short-Term Forecasting. The presentation for today's call is available on the process webpage on the California ISO website, so you can navigate there by going Stay Informed, Recurring Stakeholder Processes, and then Flexible Capacity Needs Assessment, and it'll be on that page. Today's call is being recorded, and the video file will be available for a limited time on the ISO website. The recording is for informational and convenience purposes only, and any related transcription should not be reprinted without the ISO's permission. We will be taking questions throughout the call today, and you can enter the question queue at any time by pressing #2 on your telephone keypad. I'd just like to remind everyone to please start by introducing yourself before asking your question. So the purpose of today's call is to discuss the criteria, methodology, and assumptions that are used in calculating the monthly flexible capacity requirement. And we'll be going over how we calculate the requirements for all LRAs within the ISO footprint for RA compliance year 2022, and then advisory flexible capacity requirements for compliance years 2023 and 2024. And then lastly, we'll be discussing the input assumptions and methodology of the annual CAISO availability assessment hour. So a quick overview on the agenda for today. We'll start off with a background and then jump into our process review. So that includes expected build out from all LSEs, including CPUC jurisdictional and non-jurisdictional. And then the actual load, wind, and solar 1-minute profiles for 2020 and the expected profiles for 2022 through 2024. Our calculations for 3-hour net load ramps, the expected monthly maximum contingency reserve requirements, the calculations for monthly flexible capacity requirement, and then lastly, the allocation methodology and the review of the availability assessment hours. And then we'll wrap up with some next steps. So with that, I'm going to hand it over to Clyde Lutan, and we'll get started.
Well, thanks, Isabella. Good morning to everyone. So question is, why are we doing this flex capacity study? And, flex capacity now is key to maintaining reliability in the grid. And it's not only needed to meet this throughout RAM, but also to address intra-hour variability, and we're going to get into that a little more in a few slides. So, year-ahead time frame, and so the reason why we do this again too is to make sure LSC, scheduling coordinators, they make a year-ahead, a month ahead showing that they acquired adequate flexible capacity. So year-ahead, LSC needs to secure a minimum of 90% of the following year's monthly flex capacity needs. Month ahead, LSC needs to secure adequate net qualifying capacity to meet the monthly peak demand plus a reserve margin, and embedded in that is the flex capacity needs. And hence, this maximum 3-hour ramp we expect to see each month. And then all resources participating in the ISO market under an RA contract, they will have RA must offer obligation. They are required to submit economic bids into the ISO return market, and this is what, is done today. Next slide, please. So on slide 5, the ISO flex capacity assessment is based on the current RPS expected build-out. So what we do is we send surveys out in December each year, and we expect those surveys to come back middle of the month. This year, we were expecting all responses back by January 15th. We did receive all, which is good. So a few of the things we need is for the LSCs to tell us the expected renewables build out for the next 3 years. Right now in 2020, we're looking at the binding year, which is 2022, and then we also provide advisory for 2023 and 2024. So in order to do this, what we do is we take the most recent year actual data. So we collected the 1-minute profiles for load, wind, solar in 2020. And then we're going to use that and we get into more details how we build the profiles out for the subsequent years. So also we look at the impacts of curtailments, which is that last bullet there, and we talk a little about that in a few slides. So on slide 6, the ISO starts off by looking at the CECs 1 and 2 IEPR forecast, and then that link, we won't be updating that link because I think we may be getting the CECs IEPR forecast either today, tomorrow, or by Friday. I think what I'm hearing from the latest. So with that, can you move on to slide 7? So this is an overview of the CEC's 1 and 2 IEPR forecast. Whenever I look at this, it's really mind-boggling the amount of work that CEC has to put in coming up with this IEPR forecast. So what we use here for the flex capacity study is the managed net load column. And if everything stays the same as this did last year, that was column F. So it's easy for folks to follow and see what it is we do. But again, as you can see, in order to do this detailed analysis, I think even doing the monthly forecast is a challenge. But the CEC also does an hourly forecast, and I think that's more of a challenge. When you look at this data in a day or two, you'd see a monthly peak forecast and also a corresponding hourly forecast. I think with the hourly forecast, this is what we use to develop the flexible capacity. This makes my job a lot easier. So my hats go off to the CEC for the incredible job that they do in coming up with this hourly load forecast. And again, when you look at it, you'd see a lot of variables that goes into this load forecast. I think that's a lot of work to complete this analysis. So that's a key piece that we the ISO use in coming up with this flex capacity requirement for, as I said, in this case, for the binding year, which is 2022. So if you move on to slide 8, slide 8 is we take the CEC's hourly forecast. If you look at the first top left, which is the blue, we take this is the CEC's hourly forecast, and this is just a sample for 1 day. And then we have the corresponding 1-minute profile for 2020, the actual 1 minute, which is that green curve. And we have that, as I said, for all days of 2020. So we overlay this. The thing that we do is we convert the minute by minute into an hourly average to overlay that with the CEC monthly, not monthly, hourly forecast, which is step 1 on the right. So you can see, if you look at this, because the scale is up to 50,000, it's really hard to see. But what we do is we take the difference each hour between the 2020 actual hourly forecast and the CEC's forecast for, in this case, let's say 2022. And that purple line at the bottom, that's the difference, the hourly difference for, in this case, 1 day. But we do this, again, for the whole year. And then what Hong and Jessica do is they take this purple line and they run that through algorithm where they smoothen that out to generate a 1-minute profile. We call that X that we'd explain in the next graph. So this orange line is really minute-by-minute representation of that hourly variability between the 2020 hourly and the 2022 CC's forecast. So that orange line, if you look at on step 3, that right is we have values, minute-by-minute values now that we use. And the way we use that, if you go to slide 9, and I'll step off at slide 9 to see if we have any questions. So in slide 9, what we do is we take that X, which is the minute-by-minute variability that we see, and first we generate like a 2021 in this case, 2022, 2023, and 2024. But the approach is the same. We take the 2020 actual 1 minute data, we add that X value that was calculated, that we explained in the previous slide, and that's how we come up with the minute-by-minute load profiles for the subsequent years. So let me pause there for a second to see if anyone has any questions.
As a reminder, you can enter the question queue by pressing #2 on your telephone keypad. Michelle, will you let us know if anyone enters the queue?
Yes, I will. I don't see anybody in the queue currently.
Okay, so moving on to slide 10. So now, as I said, we're looking at 2022, which is the binding year for this study. So after we calculate the 2022 1-minute load profile, and again, this is based on the actual 2020 data, and that X value that we calculated using the CC's hourly forecast and the corresponding hourly actuals that we saw for 2020. Now, for wind, we do something, now I wouldn't say similar to the load forecast. Wind is a little easier. What we do is we send our survey out each December. All LSCs, they submit back to us the expected wind solar profiles, and we ask for a lot more data that goes with it. So, for instance, we would know, and this is one of the things we ask for, is the monthly capacity. When is that additional wind expected to come in, which month? So we go back and look at 2020, the capacity that we had existing in terms of wind. So we have the 1-minute profile. So the wind 2020 1-minute profiles, we know what the capacity was in 2020. We know what the expected capacity based on the survey is going to be in 2021. And then we use that ratio to scale the wind production for 2021. So we do that for 2022. We still use 2020, but we use the capacity factor for that month in 2022 and divide that by 2020. So in this way, we account for wind. So even though, let's say, a new wind plant came in May timeframe, we will account for that wind plant in the subsequent year by taking this ratio and looking at the 2020 actuals. I'll step up to the next slide. So slide 11 looks at taking the same approach with the solar. So the solar, we have the actual 2021 1-minute profiles. We do the same thing. We know the capacity of the solar each month, and then we come up with this ratio looking at the capacity based again on the submittals by the LSE, and we use this ratio to scale the solar 1-minute values to 21, 22, 23, and 24. So let me pause there for a second to see if anyone has any questions on the way we scale load with solar.
We do have one question in the queue. As a reminder, ladies and gentlemen, #2 will enter you into the verbal question queue. Caller, your line is unmuted. You may ask your question.
Hi, thank you so much. This is Rayanne Quadra with Gridwell Consulting this morning. On the solar growth assumptions, I'm wondering if you could talk a little bit about any treatment or consideration for solar that's a hybrid with a storage implementation, and if when you're projecting out the solar that's coming in, you're separating those, how you're getting that information, and just.
So, so for this study, for this year, the hybrid, we're not going to include those in the flex capacity study, right? We did ask for that information. We're going to track it after this study period. We're going to meet internally and try to figure out how we're going to treat hybrids moving forward. But for this go around, it's not going to be included in the flex capacity study. So in other words, if you have a hybrid resource, you will not be assessed a portion of the flex capacity needs.
Okay, this is Amber. I want to expand on that. The hybrid initiative goes live in fall of 2021, and that's the anticipated date. A lot of the requirements along the hybrid initiative, which one in specific is the VER component telemetry of the renewable resources, comes along with that. So in this study, like Clyde said, it is not going to be assessed, but we are going to be analyzing it and discussing it further after that project goes live with the appropriate data and what needs to happen in future years.
Thank you so much, Amber. That helps a lot.
All right. There are currently no additional questions in the queue.
Okay, let's move on to slide 12. So net load is really the objective here, right? So we take the minute-by-minute load profile, we take the minute-by-minute wind profile, the minute-by-minute solar profile. We calculate net load. This just says, net load is a NERC-accepted term that we use, and that started way back in 2010. You can use that link to see when NERC established that net load terminology. So what we do, and almost all the ISOs, balancing authorities today, they dispatch dispatchable resources to meet net load. So another thing that we do when we meet net load is we try to minimize curtailing renewables. So we find the cheapest, most efficient units in-house and out of state to serve that net load in real time. The only thing that we really look at is to make sure that we comply with all the control performance standards. So that's the benchmark that we use, not to avoid curtailing too much renewables. So you've got to maintain that balance between supply and demand and reliability. So slide 12, move on to slide 13. So slide 13, what we wanted to show here is how net load changes from different days. So this is looking at March 2020. Again, this is actual data looking at what we saw in the system. And you can see on some days, if even you look at this on a vertical axis, on the horizontal axis, you can see how the shape changes. So the point I wanted to draw here is how difficult and challenging it is for forecasting folks to forecast where you're going to be at any hour. And as an operator, what we need to do is all those wiggles that you see, we need to make sure we have flexibility to flatten those out, to meet those variability. So this study here is looking at the maximum 3-hour run, which occurs typically during sunset. But in addition to that, we need to make sure we have enough flexibility to meet all of those wiggles that you see in order to maintain reliability on the grid. It's not just balancing supply and demand, it is also controlling or meeting, not controlling, but supporting the interconnection frequency. So on slide 14 shows the actual maximum 3-hour ramps that we saw from 2017 through 2020. And the takeaway here is really typically you see an increase. And so 2020 we saw an increase, which is blue, almost every month except January. And we talked a little about January, but typically this is what you see. And again, this is actual 3-hour ramps. This includes curtailment. So when and I'll step up to the next two slides to take questions, right? So when you look at 2020, and we showed this slide to show what we had forecasted in 2019 using actual 1-minute data for 2018 to come up with the ramps for 2020. So the blue is what we had forecasted in 2019. The orange is what we actually saw on the grid. Again, you can see January stands out. So our forecasting folks went back, looked to see if they can explain why. And they were saying, we saw some heavy cloud impact in January. That's one. And then from March through about April, we saw an impact on COVID on the loads, loads being low. And then we had some significant curtailments, which we'll get to in the next slide. And then we saw above average temperatures in August, September, and October last year. So that contributed to the difference that you see on the screen. And again, last year was really abnormal with COVID, I'd say. So it had a lot of impact. Now, if you look at slide 16, we keep track of all the curtailments. So we have, system, economic. We track this by every RTD interval, right? How much wind and solar that we curtailed. And then we go back, look at this, and if you look at what we actually curtailed in 2020 by month, you can see April, we curtailed quite a bit, May, quite a bit. So those are the heavy months, April, May, and then June, depending on, the snowpack and the melt. And I'll get to that in a minute. But then when you look at it by hours, you can clearly see the curtailment that occurs between sunrise and sunset. Right? So you can attribute that mostly to the amount of solar, not only grid, but rooftop PV production. Now, a couple of things to keep in mind with this plot. The curtailment is not straightforward. So in other words, we cannot look back and say, this is what we curtail and use that as an indication of future curtailments. You got to be careful. It's like the stock market, you cannot look back and predict a stock's going to move up or down. So here you have a few things that impact the curtailment that's not embedded in the studies. Partly it's not like hydro. If you have a good hydro year, we under hydro spill conditions, you'd expect to see more curtailments, vice versa, right? So grid connected birds, we have a pretty good handle as to what's coming in. Then behind the meter growth, we have a fairly good feel, and CC, they do a pretty good job as to what's coming in. The production, I think we still need to get a better handle on the minute-by-minute production on the behind-the-meter growth. But bottom line is, it's like you got to treat this like I would say the stock market, in that you cannot look back to predict where you're going. So last slide before I stop for questions is slide 17. Slide 17. Now, if we go back, we take the curtailments that we actually, or the renewable curtailments that we actually curtailed by hour. You factor that back into the actual 3-hour rounds. You can see the green is what you end up with. But again, it's not, like I would say, really, really close, like if you look at January. But again, 2020 was abnormal with COVID, and when you factor in back curtailment, you can see it gets a little closer to your forecast. With that, I'll stop here to see if anyone has a question on the net load slides that we show, the actual ramps and the curtailment.
Ladies and gentlemen, to enter the question queue, you may press #2 on your telephone keypad to enter the question queue. And there are currently no questions in the question queue.
Okay. So the last thing that we do after we calculate the maximum monthly 3-hour ramps, we look at the contingency reserve. And the reason why we do this, as we explained, in previous flex capacity study workshops, is during that ramp, a huge concern is if you have a contingency, then you got two things to make up. One, you got to make up that 3-hour ramp, and then two, you got to recover from that contingency in 15 minutes. So you want to make sure you have enough flexibility to meet that 3-hour ramp, and also recover from a contingency if it happens. So this is what goes in behind adding the contingency reserve requirement. We only add a portion of that, which is the spinning portion of the contingency reserve requirement. We get into that, I think, is in the next slide. But whenever you have a contingency on the system, so we got 15 minutes to get the system back to where it was prior to that disturbance. This is why, spin, non-spin, it's a 10-minute requirement. And the reason why you have that 5-minute addition is, sometimes you may not know exactly when you have a contingency, so to give the operator some time to react. In the old days, they threw in that 5 minutes to bring the recovery time to 15 minutes. But the spin non-spin requirement is really a 10-minute product. So moving on to slide 19. Slide 19 shows, the total flex capacity requirement, which has maximum 3-hour monthly ramp, which we talked about. And then we take the maximum of the most severe single contingency, or 50% of the expected, 50% of let me take that back. 3.5% of the expected load peak, which is equivalent to 50% of the contingency reserve requirement. So this is the formula we use. Pretty straightforward. We do this for every month, and we add that to the maximum 3-hour ramp to come up with the flexible capacity needs for that month. As all the previous years, we never really added that epsilon to correct for the errors that we saw in the previous years, and we're going to stick to that. This can go around. We're not going to use any values for epsilon, so it's strictly going to be the first two pieces of this equation. Moving on to slide 20 before we stop. Slide 20, well, we wanted to show a couple of things here, right? And when we started doing these studies many years ago, the ramps, it was more or less close to being evenly distributed, where, each hour you'd see more or less similar type ramping needs. What we started to notice over the past few years is the 1-hour ramp within that 3-hour ramp could be greater than 50% of the 3-hour ramp. So this is a clear indication now that the ramping needs in the system is increasing, because when you look at the values here, like if you look at February, 7,800 megawatts in an hour. These are a lot. So you look at February, you look at April, March, you look at April, November, December, they were all greater than 7,500 megawatts, more or less. And to put this in perspective, this is like moving 3 times or greater than 3 times sub peak load in an hour. That's a lot of energy to move in an hour. Being able to predict that accurately, being able to move resources to meet that ramp, and hence need for speed. Now, one thing we never really get into, but I just wanted to cover high level, is when we meet these ramps, a lot of folks look at it and say, well, you're looking at minute by minute debalancing, even though let's say in 5 minutes you balance 1 minute and then you don't balance the other 4 minutes. Well, we get impacted. So how well we control the grid by how well we do this balancing every minute. So that's something I do not want to get into here, but having the flexibility is key to maintaining reliability. And so every year we do this, we go back, look at what we're seeing in the system that's new, and try to share it with this group. So slide 21, so let me pause there for a second on slide 20. See if there are any questions on this.
Once again, ladies and gentlemen, #2 will enter you into the question queue. And there are currently no questions in the queue.
Okay, so moving on to my last slide is what does the ISO need? Well, the CCI forecast, which is we're going to be getting that, as I said, within the next couple of days. The LFCs build out for renewables. We've already collected that, so it's just a matter of looking through that data set to start the analysis. So I think with that, we have what it is. We ask for what it is we need to move forward with this study. And with that, I think this is my last slide before I pass this on to Han. I wanted to just make sure that we didn't, we answered all questions on my portion.
Are there any questions in the queue?
There are currently no questions in the queue. #2 will enter you into the question queue, ladies and gentlemen.
Okay. So just before I pass this on to Hong, so when we calculate the flexible capacity needs, Hong takes this need and then he looks at certain things which he's going to get into to do the allocation. So with that, I'll pass this on to Hong to go into a little more details to how he calculates the allocation. Hong.
Yeah, thank you, Clyde. This is Hong. And when we finish the requirement, the Clyde's part, what do we have? We have 4 pies. The 5 pies actually is the first one is the net load requirement. Then we have the reserve. Then for the net load requirement, we further got 3 small pies, and one is the load, one is the wind, one is the solar. So what I'm doing or have been doing is to cut these pies to allocate to the each LSEs or SCs. So the next 2 slides is kind of brief description, or 3 slides brief description what we are doing. And so got a little notation table here to help facilitate my kind of formulas. Use the symbol. I'm going to go through the tables. The L, W, S, NL is kind of standard. It's load, wind, solar. NL is net load, which is load minus the wind minus solar. The ramp or the difference between this time point to that time point, I use the symbol is a delta there. So naturally, the net load ramp is equal to load ramp minus wind ramp minus solar ramp. So add a little year there to indicate this requirement. So what class after all the study, all the calculations, analysis, then we will have the estimate how much net load requirement we're going to have. As well, from that study, we are going to have how much the load ramp will happen in the maximum 3-hour ramp in the load, and in the max 3 hours of net load, how much is contributed by the wind and by the solar. So we have the delta NL 2022, delta NL 2022, and the delta L, and the delta W, delta S, all for the 2022. So that's the pies I'm going to start with to allocate. Then a small pie, very small pie is the reserve. So that is have the equations Clyde has already showed in his previous slide. Then a few more, two more. One is the CEC peak load ratio. This is get the load ratio for peak load ratio for all the LSCAs, LRAs in the Newcastle territory. So we use this CEC peak load ratio to slice the pie of the reserve. That's the easiest part of all the allocation. So the last is the summation of all the LSCs or SCs. So then what we have is we have this 2020 load from the CEC. Then we have the survey. That's our source doing this proportion. Then we have the CEC peak load ratio. And next slide, please. So before I go to this, I hope there is no questions about all the. I just very briefly described all this notation. So just in case if anyone has any questions. Okay. So then what do we have? As I said, we have this one big pie is the load ramp, net load ramp of 2022 plus the reserve 2022. So we're going to gradually, like in the fashion of the pinning the awnings, and by each part, how we do this slice. For the reserve part, as I said before, we are going to each SC or LC will receive the peak load times the total reserve. That's easy. So now we're going to the net load slice the net load. So net load is equal to the load ramp and minus wind ramp minus the solar ramp. So then we further to doing this proportion of the wind and the solar. So wind and the solar is by the proportion select at the high of the wind of the ramp of the wind 2022 by the proportion of how much nameplate capacity submitted in the 2022 survey for each LC. So the bottom is for that fractional, the bottom, the denominator part is the total survey megawatt, and the numerator is summation of each SC's the megawatts, and then that's the proportion. So this proportion is the same, similar for the solar. So we have the reserve part, we have the wind part, we have the solar part. So they are all doing kind of easy, straightforward proportion of doing this slicing. However, the load, if we're trying to do this straightforward proportion, we are running into some problem. We can do the ramp proportion, but then we cannot do that. The reason is the system ramp may be 0, so that will be messed up the whole thing. And also, can go to the next slide, please. And also, some LSEs trying carefully not to have a big ramp in the maximum 3-hour, as those maximum 3-hour ramp. They're trying to manage their load to reduce their load. Then the LS, so they are in the 2020, in the previous year, they will have the trying to manage the ramp in 2020. So we need to give the credit of how they're doing, and also it serves as incentive for all the rest of the SEs or LCEs to get smaller the load ramp. So then our ISO total net load ramp will get smaller. So the total load part is the slicing of doing this allocation is have 2 parts. One is how much credit we assign to the LCEs, SCs to their load ramp management. Then the next we do the incremental of the 2022 of total system ramp minus the total ramp of 2020. Then we do the proportion. So the each SC will receive the first part is the credit or incentive part. The next part is kind of doing the second part is doing the proportion. So all in all, we have the reserve, either the proportion of the allocation is by the peak load ratio. The wind and the solar is doing by the ratio of the survey from the 2022 flexible ramp survey. Then the load is doing little extra, is to give the credit to the LCEs, SCs manage the load ramp, and then the peanut butter, the difference between 2022 and 2020. So that's the allocation formula has been used for last 2 years. This is the 3rd year we're going to apply the same formula, and there is no change of the allocation formula. So I pause here for the questions or suggestions.
Once again, ladies and gentlemen, #2 will enter you into the question queue. And there are currently no questions on the line.
So I'm going to pass it over to Jessica.
All right, thanks, Hong. So just take a quick minute to quickly review the annual availability assessment hours methodology. So we use the CEC IEPR forecast, as mentioned in previous slides that Clyde had talked about, to get the hourly average load by hour by month. So these actuals from 2020 and then the forecast from 2021 through 2024 to calculate the top 5% of load hours within each month using an hourly load distribution of the load in that month. And then we use that information to calculate the availability assessment hours by month for the years 2022 through 2024. So it's no change from our methodology from previous years. Those remain the same. And just a quick review over the information we've requested and obtained. We've published a market notice in December and January requesting the LSC survey data, which was due on January 15th, 2021. We're still waiting on the CEC hourly IEPR forecast, which is anticipated to be finalized and published hopefully by the end of this week to continue with our Flex RA process. And then last but not least, we'll go over some of the next steps. So we have our stakeholder call today. Comments for the stakeholder call will be due on February 10th, 2021. Our next stakeholder call to go over the preliminary results of the flexible capacity and availability assessment hours requirements is scheduled for March 31st, 2021, with comments due for that on April 14th. However, there might be a delay of the next stakeholder call due to the delay in the CEC IEPR forecast. So those dates are tentative and may change going forward. In April, sometime we will publish the preliminary results for the flexible capacity and AH requirements, and then in May we will issue the final results and paper for 2022 requirements and the projected requirements for 2023 and 2024. And that is all we have for today. This is Amber. I just wanted to add, just for those that are on the call, I know we try to get the final information posted by May 1st if possible to meet some other deadlines. But this year, just like last year, it does look like it's going to be more mid-May and potentially later just because we have to wait for the CEC IEPR forecast to get published. So I just want to make sure that the stakeholders are aware of that. That's why it just says May of 2021, and we'll update the schedule as needed, but at the earliest, most likely May 15th.
Thanks, Amber. Before we wrap up, are there any last questions? Again, you can enter the question queue by pressing #2.
And I do not see any questions in the queue.
Okay. And just as a reminder, comments are due on the assumptions and today's stakeholder discussion by February 10th, and you can submit those to initiativecomments@CAISO.com. With that, that concludes today's stakeholder call, and thank you all for joining us. Have a great rest of your day.
That concludes our conference. Thank you for using Event Services. You may now disconnect.